Okay, my name is George Martin, and along with my wife Artie, we're the event supervisors for Simple Machines. This is the third year, I think, in this iteration of the event. We did it for 10 years and took a break, and now we're back to it. The design of the competition is fairly simple. There will be 10 stations. Students will be given 2 minutes at each station. And each station will have 10 questions, giving a total of 100 points for the competition. When they arrive at when they come into the room, what's going to happen is I'm going to bring 20 teams into the room at one time. So I'm going to have 2 complete duplicate sets of the 10 stations. Students will be directed to go to a station, any station. Doesn't really matter where they start, they're going to do all 10. Every 2 minutes, they'll move to the next station. So if they're at station 1, they move to 2. Station 5 moves to 6. Station 10 goes back to 1. That type of thing. When I do it at the county, I set the stations up in a circle. So they just go around the circle. They just go in the same direction around the circle, and they hit all 10 stations. Really, like I said, fairly simple. So, what are they going to find when they get to the station? When at all possible, what they're going to find is a physical object that they can pick up, hold their hands, manipulate, turn around, and say, oh, that's such and such a machine. That's the ideal. Now, that isn't necessarily going to work for every station.
Is this the 10:30 or the 11:30 starting? Or?
Yeah, this is it. Yeah. Like I said, whenever possible, it's going to be a physical object they can pick up. In some cases, what they're going to find are pictures of or drawings of various devices to identify. In some cases, I'm going to actually construct an apparatus of some sort. The most common example of that is I have a bit of a frame, and I will put one or more pulley setups within that frame for them to look at, compare, examine. The first 5 questions at each station will be some form of identify the machine. It can be as simple as a question that says, does this machine involve a lever? Yes or no? It can be that simple. They may get a set of pictures, and the question will be, which of those 5 pictures represents a lever? Pick the answer. So there'll be, in a way, you'll have a sort of some true-false questions in effect, some matching questions. They're all going to be done multiple choice, and everything's going to be done on a Scantron sheet. Does everybody know what these things are? I got a few up here if you want to look at them. They need to come in the room knowing how to fill this out correctly. Frankly, I'm not going to have the time at county to manually score every one of these sheets. They're going to go through a reader. Okay? So, first 5 questions are identify the machine. The next 5 questions will test their ability to understand various concepts of simple machines. They may be asked to identify the parts of the machine. If the object is a lever, I may ask them to identify where's the fulcrum, where is the load applied, where is the load, where is the effort applied. Okay. When I do that, I'll stick little labels on points on the machine. A, B, C, D, something like that. And they'll tell me, and I'll ask them, you know, which point is the fulcrum, for example. Okay, fairly simple. They may be asked to measure, make a measurement. I may ask, again, using the lever as an example, I may ask them to measure the length of the effort arm. The effort arm being the point, the distance, the straight line distance from where the effort is applied to the fulcrum. I may ask them to measure the load arm. Again, fulcrum to where the load is lifted or moved. Yes?
Will the measuring device be provided?
Yes. I will provide rulers to do that with, and I will also provide scratch paper. I don't want them bringing anything into the room that they don't have to. Quite frankly, they should be able to walk in with a pencil. That's it.
Are you measuring metric or?
Okay, well, I was just getting to that. See, I reserve the right to select that measurement in inches or centimeters. And the reason I will do that is to make that measurement as close to a whole number as possible. If my choice is 7 centimeters or 3.56 inches, I'm going to go with centimeters. You know, I'm going to use the measurement system. That's another reason why I will put the little labels onto the device, so that I will put those labels exactly 7 centimeters apart, so that the measurement is quick and simple. Yeah.
Okay, 2 questions. One, if you're using different measurements, are you consistent with each station with one measurement, or do you switch
Oh, well,
back
they
and
will
forth?
be there. Remember, I'm doing multiple choice questions.
Right.
So all of the answers will have the same unit of measurement.
Okay.
I will not mix.
And there will be no conversions that the kids will need to
No,
be
they
done?
will not have to make conversions. They will not have to make conversions. No, it's really simple. Like I said, the reason I am going to pick the measurement unit is so I can keep the numbers even, or whole numbers or simple fractions wherever possible. Okay. Some calculations will have to be made. These are, again, going to be simple calculations using whole numbers as much as possible. What type of calculation? I may ask them to tell me what is the mechanical advantage of this device. Well, if the load arm is twice as long as the effort arm, you have a ratio. That ratio gives you the mechanical advantage for our purposes. Again, for our purposes, there is no friction. Everything's ideal. We're just not getting into that. Not at this level. If this was a high school event, then all bets are off. But this is elementary school. Okay. But yeah, I'm going to keep the calculations as simple as possible. They may be given a question that essentially says, you know, like again, I said the lever arm and the effort arm are different by a factor of 2. And I say so much effort is applied, how much load can I lift? They should be able to make that calculation easily enough. All right. These are the concepts they need to know, and all of it's in the handout. Okay, again, as I mentioned before, I'm going to provide rulers and scratch paper. None of the calculations are going to require a calculator. As such, I will not allow a calculator in the room. Okay. All they really need to walk in with is a pencil. And if they come in with a single pencil and it breaks, they can raise their hand and I will hand them another pencil. Think I've done that just a few times? Okay. So, the next question is, how do you prepare your students for this event? The best way to do it, there are plenty of resources out there, elementary science textbooks. Anybody here an elementary teacher? Can tell me? Okay, what grade is simple machines being taught this year?
Third and fourth in my school.
Hmm?
Third and fourth.
Third and fourth?
Third.
Third, okay. So, you know, get a hold of, if you're not an elementary teacher, but you can get your hands on one of the textbooks from the third or fourth grade, you should be able to do fine there. I'm going to forget the name of the author, but there's a book that's been out for 20 years called How Things Work that has a really nice section on simple machines in the beginning. It's all done with mammoths. Nice, good book, covers a lot, covers all the basics. Beyond that, there are tons of websites out there. You go to Google and type in simple machines, it's amazing what you'll get. Although you will have to avoid, I believe there's a rock band called Simple Machines. So ignore that one. All right. Beyond that, send your kids to the library. Now, after they've got the basics, the thing to do is open up your toolbox. Open up your kitchen drawer. Make the kids take these things and look at them and try to figure out what they are. Common objects. As much as possible, I'm going to use common objects. They should be able to identify simple machines in the real world. Now, that said, I've run into a couple of issues in the last couple of years that have kind of brought home to me the fact that it's amazing. Not every kid, not every third to sixth grader knows what a bottle opener is. Bottle twist off, right? Well, so one year, one of my competitions I've used for years, I've used a bottle opener. And yeah, that's created some issues. I've used pictures of things like farm implements, like plows. They have no idea what this is. So why broaden their experiences? Find just any type of mechanical device and let them look at it and try to figure out what they think it is, and help them learn. Okay. The first year we did the event, every single station came out of my workshop, out of my toolbox, or out of the kitchen drawer. I've expanded a little bit since then, but I'll give you an idea what the focus of this event is. Okay. Are there any questions?
You said the first 5 questions were ability to identify machines, and what were the second 5 questions?
The second 5 will test their knowledge of concepts, like how the concept of mechanical advantage, or identifying the parts of the machine, measuring, that type of thing. There'll be some calculations there. Trying to think what else. Yeah.
So I'm hearing you have understanding work.
Yeah. They understand those basic concepts that force times distance. They'll do just fine. Like I said, what I'm looking for is them to be able to get the gross idea of how it works. One other example that I might give is I might give essentially 2 different sizes of the same object, and which one has more mechanical advantage. I may give them a question to, okay, given this device, if this portion were made longer or shorter, how does that change the mechanical advantage of the device? So again, they need to be able to understand the basic concepts. Yeah.
My one concern for myself as a first year and an engineer myself is my ability to scale it down to a 9 or a 10-year-old's level. Do you have any suggestions for materials beyond a science book, which I've been told I'm not going to be able to get my hands on?
Oh.
On how I might be able to scale that down and level my own knowledge?
Okay.
Maybe a website that you're familiar with that might work well?
You know,
for
there's
that?
so many of them out there. There's some very good ones. I don't have a list at the moment.
Edheads.org was
What's
one
that?
of Edheads.
Oh, Eggheads.
No, it's just ED heads.
Oh, Edhead.
.org.
Okay.
And there's actually a simple machine quiz that kids can actually take. I did it with my
Okay.
daughter, just to kind of
Okay.
just show.
Yeah,
Okay.
but you have a very good point. If this, like I said, if this were a high school event,
Oh,
I
yeah,
would be having them calculate ideal mechanical advantage, then experimentally determining actual, then tell me the efficiency,
Right.
you know, all of that stuff. The other thing that you're going to find is, as an engineer, you don't really care about identifying the machine, as long as you know how it works. You don't really you're not really that concerned with putting a name or a label to it.
Right.
But at this level, we're more interested in the kids identifying labels.
So just to make sure I'm clear, what you have here with the simple machines identified and the formulas you've identified,
Yeah.
this is the focus.
Yes.
This is where I should primarily
Yes.
focus, and don't go beyond this, because then I'm taking up brain space.
Exactly.
Okay.
Yes, that's the best way to do it.
Very basic.
Okay. That's what I need to know.
Yes.
Are you going to do a workshop for the students?
No, actually, I did a workshop a couple of years ago, and the video is on the website along with just the PowerPoint. That you can just run through the PowerPoint slides, or you can, if you're a glutton for punishment, you can watch me speak for an hour. But yeah.
You've done this event before, so
Yeah.
are there past tests available online?
I don't have anything online right now.
I found two of them, they were on the website, the ESSA.org, there were two tests, one from '08 and one from last year.
Okay, actually, those have been taken down now.
Oh, they are?
As far as I know, they've been taken down. But, yeah. The main change that you're going to see, I think, from past years to this year, in past years, literally the first 5 or 6 questions were simply, look at the object, is it a lever, yes, no. Is it a pulley, yes, no. Is it a wheel and axle, yes, no. You know, like this. And I'm kind of getting away from that, because quite frankly, I'm trying to make the test a little more difficult, because I've got 100 questions and 77 teams, and I don't want to break any more ties than I have to. That said, those first 5 identification questions are the ones that will be used as the tiebreaker. As long as they can identify all the machines, that'll give them a leg up on the tiebreaker. For what it's worth, I had one team last year, one team that managed to get all of the identification questions correct. Out of 80 teams, I had one that managed to get all of those correct. So whatever. The other change, and this is on the handout, in the past I have said that I would not ask the students to identify first, second, and third class levers. I've decided that that's now fair game. Everything you look at that teaches about levers teaches you first class, second class, third class. Therefore, I've decided that is fair to ask.
And then easier to calculate the mechanical advantage also if you know which class of levers. Because some class of levers will have mechanical advantage less than 1, like third class lever.
Exactly,
So if
yeah.
you know the class, it will be easier for you to
Yes. Yeah.
double check
Yeah.
your answer.
Now, will they be asked to identify which class specifically, or any questions related to the differences between the classes?
At this point, what I anticipate is just asking them, which class of lever is this? is it a first class, first, second, or third class? And because when they get like that third class lever, that her example where the mechanical advantages may very well be less than 1, they'll probably get a question about the mechanical advantage on that one.
Okay.
And so I don't anticipate any questions just compare and contrast first class to second class or that. No, I expect these questions to be related to the object on the table. Okay? And I don't know, maybe that's one more point of difficulty that might help reduce the number of ties. I don't know. We'll see what happens. We have been toying with the idea of making some questions 2-point questions and some will be 1-point questions. I'm not going to do that this year. We're going to see how this year goes and see if I really do need to do that. You know.
Are we going to have descriptive questions, like they have to write in sentences or?
No. Everything's multiple choice. Everything has to be answered on the Scantron sheet.
Right.
Yeah. If they, and that's as much for ease of grading as anything else.
Right.
Yeah. So everything's going to be multiple choice. All right. Any other questions? Just out of curiosity, how many of you are doing this for the first time? Oh boy. Okay. Yeah. All right. No, not too many veterans in this one then.
Actually, this is the first time our school is participating, so it's kind of a new game for the school too.
Oh, okay.
Yeah.
Yeah, very much so. Yeah, I was looking at the list of schools this year because I'm kind of curious with the Wayne Oakland doing their own thing and we're losing some of those schools, how many teams we have. And I noticed a couple of school names that I didn't recognize from past years, so.
I think you should make it a little bit simple so kids can do it.
I do have another question.
And we don't, my son studies in 4th grade and I don't think this school teaches simple machine. So,
right.
I mean, not that,
Yeah.
but still a little bit of encouragement will keep it going for our school.
Sure.
I do have an actual related question. I noticed they're selling kits
Yeah.
for each one. Is there a kit for simple machines?
No.
Okay.
Not at all. Not at all.
You can buy it.
That's what I figured. I just wanted to make
Designed to help
sure
for
so I could
school,
at least
yeah.
look at it and
Yeah.
see what's included.
It's not
but-
applied for this, but they do have kits
But,
available.
just to kind of elaborate a little bit, when they get to the station, then, when they get to a station, they might find a screwdriver or a pair of scissors or a pizza cutter or, these are all things I've used in the past. There will be one station, as I say, that'll have a framework with some pulley setups in it. That type of thing.
I think that you do in March, right? Month of March, you actually demonstrate that to the event table. And sometime in March, you do that workshop.
Well, okay, there are various districts do district competitions, and usually I'm at all of the districts. This year I've got a conflict for a couple of them, but I'm going to provide the tests and the materials, so hopefully that it's going to be the same thing at all the districts.
So last year I attended that, it was very useful. There was event table, there was pulley arrangement, you should attend that, if it's available. Last year you did that.
Yeah. All right, if there are no other questions, I'll let you get on to the next station, or the next session.